In the middle of the Caribbean Sea lies a perfectly circular hole so massive it can be seen from space. Its dark blue center plunges deep beneath the ocean surface, hiding ancient secrets, underwater caves, and clues about Earth's distant past. This giant underwater sinkhole, known as the Great Blue Hole, sits nested within the shallow lagoon of the Lighthouse Reef Atoll. It lies off the coast of Belize, anchored inside a protected reef system that spans the outer edge of the Caribbean. From high altitude, the transition is sudden and absolute. A pale ring of coral gives way to a dark indigo void. The geometric precision of the feature is what makes it so striking. Nature rarely produces flawless circles of this scale, yet here, the boundary is clean, sharp, and seemingly deliberate. This perfect circle presents an immediate geological question. It resembles an intentional design rather than a random natural occurrence, an anomalous eye resting in the middle of a shallow marine environment. This circular boundary serves as a gateway. While the surrounding reef thrives with life and light, the dark center remains cold, still, and largely hidden. The contrast between the bright, shallow waters of the atoll and the dark circle at its center is the starting point for a deeper inquiry. It remains a silent, enduring question on the ocean floor, holding clues to a story that begins at the surface but extends far into the dark. During the last glacial maximum, approximately 20,000 years ago, massive ice sheets locked up vast amounts of the planet's water. Sea levels fell by more than 120 meters, exposing the ancient limestone platforms of the Caribbean to the open air. Rainwater, absorbing carbon dioxide from the atmosphere and soil, became slightly acidic as it filtered downward. This weak carbonic acid slowly dissolved the porous calcium carbonate, expanding minor fractures in the bedrock into towering vaults and massive subterranean chambers. Geologists refer to this terrain, shaped by the dissolving of soluble rock, as karst. Inside these dry, air-filled caverns, mineral-rich water dripped continuously from the ceilings. Each drop left behind a microscopic trace of calcite, slowly building geological structures over thousands of years. These cave mineral formations, called speleothems, grew into heavy stalactites hanging from the roofs and stalagmites rising from the floors. Scientific analysis of these formations records 4 distinct growth phases, approximately 153,000, 66,000, 60,000, and 15,000 years ago. These dates confirm that the chambers spent long stretches of geological history completely dry. The stability of these enormous caverns changed as the Ice Age drew to a close. Melting glaciers caused global sea levels to rise rapidly, and the ocean surged into the freshwater cave systems. The rising water filled the hollow spaces, and the massive weight, combined with millennia of structural wear, proved too much for the hollowed-out stone to bear. The cavern roof failed, collapsing downward in a single catastrophic event. This left behind a vertical, circular shaft that the rising ocean quickly submerged. The resulting chasm is a geometric anomaly of immense proportions. At the surface, the opening measures approximately 318 meters across, a distance spanning more than 3 football fields laid end to end. This vast, nearly perfect circle covers an area of 70,650 square meters of open water. Below, the limestone walls plunge vertically to a depth of 124 meters. To put that scale in perspective, the entire Statue of Liberty, from its pedestal to its torch, could be submerged within the dark waters with room to spare, while a 40-story skyscraper would sit entirely hidden beneath the surface. Beyond its sheer volume, the structure is striking for its precise geometry. In a natural world dominated by irregular fractures, the perimeter of this massive sinkhole remains incredibly clean and symmetrical, resembling an engineered monument carved straight into the ocean floor. In 1971, the French research vessel Calypso anchored inside the Lighthouse Reef Lagoon, bringing the dark sinkhole into global view. Under the direction of oceanographer Jacques Cousteau, the crew deployed early submersible chambers and experimental scuba gear to penetrate the darkness. The divers faced severe technical hurdles, including a toxic hydrogen sulfide layer at 90 meters that threatened their breathing equipment. Despite these dangers, the expedition produced the first physical proof of the sinkhole's dry origin by recovering massive, submerged stalactites from the flooded ledges. The presence of these mineral formations confirmed that this chasm was once a dry cave system that collapsed under the weight of a rising ocean. Decades after Cousteau's early dives, exploration shifted from visual curiosity to high-resolution measurement. In 2018, a modern scientific team returned to the site with a fleet of advanced submersibles, including the three-person Stingray 500. Guided by sonar pilot Erica Bergman, researchers captured the first complete three-dimensional digital scan of the entire interior. Equipped with a Kongsberg multi-beam sonar and an advanced inertial navigation system, the expedition recorded over 1 million acoustic returns. This effort mapped the rugged limestone walls, hidden side conduits, and terraced steps, converting the physical structure into a precise digital replica. This transition from early human risk to automated acoustic scanning transformed the sinkhole into a highly detailed laboratory of planetary history. Hanging from the limestone ceilings of these submerged ledges are massive stalactites, some stretching 15 meters in length. These stone pillars, frozen in time, could only have formed in an air-filled environment, proving that dry caverns once existed where the ocean now rules. The walls themselves are carved with step-like terraces at depths of 21, 49, and 91 meters. Physical records of the exact levels where the rising sea paused during its ancient march upward. As researchers descend past 90 meters, the water column undergoes a drastic chemical change. Dissolved oxygen vanishes completely, replaced by a dense, toxic layer of hydrogen sulfide that creates a hostile environment where ordinary marine life cannot survive. This lack of oxygen prevents decay, preserving organic matter that falls to the bottom. Below this toxic blanket, the quiet floor of the basin holds the ultimate geological prize, a continuous 30-meter-long column of sediment spanning the transition from the Pleistocene to the Holocene. By extracting these core samples, scientists can read the fine layers of mud and sand like pages of an ancient diary. Coarse sand grains within these layers mark prehistoric hurricanes, while stable isotope ratios in the calcite preserve a detailed timeline of rainfall patterns, sea level changes, and temperature fluctuations spanning over 150,000 years. Above the silent abyss, the sunlit rim of the sinkhole supports a thriving marine ecosystem of more than 100 coral species. Caribbean reef sharks, bull sharks, and Nassau groupers patrol these shallow flats, while schools of snapper and giant rays glide along the drop-off. This vibrant border has made the site a global diving landmark, anchoring the economy of coastal communities like San Pedro and Caye Caulker. Local guides and boat captains act as the modern guardians of this reef, where a single excursion generates hundreds of dollars in tourism revenue, securing Belize's identity as a premier sanctuary for ocean exploration. Today, this submerged giant stands as a silent sentinel. As modern climates shift, its dark depths offer a stark warning of how rapidly our world can change. The abyss is not just a relic of the past, it is a mirror to our future. Share your thoughts below.